My name's Daniel. I've been working a lot on the Blink side of the site isolation changes. So I'm just going to kind of talk about what we changed and kind of what needs to be done to kind of get the rest of Blink working with kind of what we're doing. Uh, so to start with, this is just kind of a diagram of the original kind of architecture in Blink. You can see at the top we have the embedder layer. We have WebFrame client, which is implemented by Chrome. And then in the web layer, we have WebFrame, and frame loader client is the bridge in the core. And then from there, you have frame, DOM window, document. It's all pretty straightforward. Things kind of correspond to what you think they mean. And so to make this work with site isolation, we had to add a bunch of classes. So you'll see that in the middle, we still have these common base classes, WebFrame, frame client, frame, and DOM window, that are implemented by both the local frame and the remote frame versions. But other than that, they're essentially kind of parallel hierarchies. So if you have a web frame client, it's always going to belong to a web local frame with a local DOM window, all that stuff. If you have something that's remote, it's always going to have a remote frame, remote DOM window, that stuff. You'll never kind of mix and match. Something that's not really covered in here is frame owners. So today in Blink, frames need to know their owner element. This is used for things like firing the load event at the iframe element, and also for things like sandbox flags, which are checked during the loading process. And so originally, this was implemented with something called HTML frame owner element. And by definition, since it's kind of based on an element, it assumes that the owner is in the same process. But when you're cross-process, you can't really access that element because it could be another process. So to fix that, we've kind of abstracted these details into frame owner, and right now that just has sandbox flags and the load event stuff. I don't know that we need anything else in there, but that's kind of the basic idea. Where we have something that was local specific, we lift the functionality that needs to work for both up into a common class, and then we have local and remote versions. I haven't looked into it, so I don't know. So the question is, what about window.frameElement? And the answer is, I don't actually know. I'll give it a try after this. Yeah, it doesn't seem like something that should work across origins, but I should double check just to be sure. So how do you get remote frames? So newly attached frames always start as local frames in the parent. So if you create an iframe and stick into the DOM, no matter what the source is, we always start as a local frame, and that's because it starts at the initial empty document. And so on navigation, the browser process will make a security decision. If it decides that we need to make, render this thing in a different process than the parent, for security reasons or whatever, it can choose to move that frame to a different process. And there's a little magic involved here, but the basic idea is there are some important things on the frame that we need to preserve. And most of these are just like the pointers for the frame tree, but there's a couple other bits of state we need to copy around to, and we just swap those to the new frame. And it's just like swapping a node in a linked list or a tree. So that's the theory. And frames can also go from remote to local. So, if you have a child frame which transitioned away at some point, you could navigate it back. And, if it's in the same site instances as its parent, it would go back to being local in its parent. So there's a tricky bit. Blink has something called a provisional load. And so what that means is you can have a load, and you don't actually know if it's going to result in a page navigation where we load new content and render a new page. And when this is kind of pending, we call this a provisional load. And the problem is this loading machinery kind of depends on having a local frame still. So if you have a navigating web remote frame, we end up partially linking a web local frame into the tree, and we call it a provisional local frame. And it's kind of weird. So you see the child web remote frame has a parent pointer to its parent, and its parent has a pointer to it as well. But the provisional web local frame only has a pointer to its parent, and the parent doesn't know about it yet. So if the navigation actually results in committing a new page, we swap out the remote frame and we replace the old remote frame with the provisional local frame. Um, you'll see there's a few edge cases related to that in the frame swap code. Hopefully you never hit it. Otherwise, if the navigation doesn't commit, like for example, it results in a download, we just throw away the provisional web local frame. It just gets deleted and everything stays as it was. So there's kind of a project underway right now to remove this sort of hack from Blink eventually. It's called Please Navigate. And the idea is the browser process will kind of do the initial parts of the load up until it knows an actual page load is going to happen. At that point, we start committing data into Blink, and we don't need this provisional thing because we already know it's going to load. And that'll simplify and get rid of some of the. You'll see in the code there's a few edge cases where you have to check if the parent and if we have some configuration of frames, we can't do this because it's actually a provisional local frame. It's quite ugly, but hopefully you never see it. So next is the frame tree. So the thing is, code used to kind of assume it could reach in every frame in the frame tree and grab out whatever it needs. If it needs to grab out the render for an element, or if it needs to check something off the document. And so you see a lot of code that just says for frame F, and then just iterates through all of them and does something. And for now, we've changed a lot of these to explicitly check if the thing is a local frame and just continue if it's not. And this is kind of a band-aid solution for now. I'll talk about this more in a little bit. But a lot of these changes you see was basically just so we can make code compile for now. So obviously, a lot of code that does this is not going to work well with site isolation stuff, but at least it won't crash. So here's an example. I'll cover that more in a sec. So the question was, do we have like a tracker for all these, checks for is local frame? And hopefully it'll become clear in a few minutes. So this is one particular example. Security decisions, kind of by their nature, often have to cross frames, right? If you're loading mixed content, you need to know what's HTTP, what's HTTPS, that sort of thing. And often you'll see code like this that's doing security checks. It just uses local frame specific members. And if you have a remote frame, there's no way you can do this, right? A remote frame doesn't have a frame loader, so we can't do any of these checks. It doesn't have a document, so we can't get to the security origin. So our strategy is to make these decisions available through frame itself. So this particular example, this isn't actually done yet, but in some theoretical world, we would make mixed content checker somehow available through frame itself. And the part that's already done is we've made security contexts available through frame. So you can get security contexts for remote or local frame, and you can get its origin and other useful stuff from it. And that way you can make these decisions without saying, if this is local frame, do this, otherwise do that. And that's kind of our approach to a lot of these problems. If there's something, that should work for both, we try to lift the abstraction into the base class for it, and, try to hide the logic with virtual dispatch. And the idea is, once this is done, we should have very, very few is local frame, is remote frame, and, the downcasting stuff. And we can go and manually audit these, make sure they're needed. So like the end state should be very few of these checks. Obviously we'll need a few of them, but it should be pretty minimal. So this was kind of covered earlier, but the idea is the browser handles the details of all the replication, and the render just uses this replicated data. The browser obviously still has to make the final security decisions because we can't really trust the render, so we still need the browser to kind of provide the the final decision. And currently, I think only security context is kind of replicated in this way. Window.name is actually now. I think Alex just landed some of those patches recently. And we might use this infrastructure for a few other bits of data that need to be replicated between renders. Something we'll be evaluating as we continue porting features. Another thing we had to change is kind of how rendering and layout works. So right now, when you do layout and rendering, a lot of this is based around WebWidget. And the problem is, if you're rendering frames that are in other processes, those child frames don't know where they should draw into their parent. And so the solution we've been pursuing is each renderer kind of draws into its local view of the world, each frame, and we use the browser process to kind of composite all these results together. Um, so each web view right now is a web widget, but the problem is you can have child frames in the same site instance in the same web view. If you have this example page right here, a.com with two b.com child frames, the b.com frames are both going to be in the same renderer, and they're going to both try to talk to the same web widget. And this is a problem because you can't really maintain two different sizing infos on the same web widget. I mean, we could theoretically make it work, I guess, but it would be super complicated and ugly. And so our solution, both child frames will have to use their own widget for layout and rendering purposes, and this solves the collision. So who gets a web widget, right? So we kind of mentioned this earlier, I think with the frame group idea, but the idea is we have this concept in Blink in the render called local root, and its local root is just the root of a subtree of connected local frames. So every group of connected local frames without any remote frames in it is considered, a subtree, and the root of that subtree is the local root. And each local root will have a web frame widget. So this is just a simple example. You have that top level web local frame, which obviously has a web frame widget. And then you see the two local frames rooted under the remote frame each have their own web frame widget because those two aren't connected directly to each other, so they both need their own widget. Yes. So the question is, if I'm simplifying it correctly, is why not simplify and use one code path for everything for rendering instead of going through different things for remote and local? Well, remote frames don't really have anything to render right themselves, right? They're just kind of a placeholder for something in another process. So like it won't know what to draw at all, right? It doesn't have the DOM, it doesn't have anything from that. Um, that's a good question. So the question is, so if you have two local frames, one a child of another, why don't they both just go through the browser compositing path? I don't know. Um,
Sorry, Daniel, what was the question?
so the question was, why don't we always use the browser to composite all the frames, right? So if you have a local frame that's a child of another local frame, why don't we depend on the browser to do the compositing there instead of,
So like
having,
everything would get a widget in that case? Is that
yeah.
what you're saying? Uh, we discussed that a long time ago, or like when we were starting the project. I remember Albert and John Abdel Malik and I talked about it, and the thinking was that it would be far too heavy in terms of resource requirements, and it's a lot of extra and a lot of extra IPCs and messaging and infrastructure that gets set up. So that was why we decided against that.
I mean, it kind of depends on how many of those iframes end up collapsing in the same state instance and those sort of things. It's hard to say. I it's theoretically it's possible we could do all the compositing, in the browser. There are some costs to that, right? You need to create a widget for each thing. I don't know the actual overhead myself because I wasn't actually part of the team probably when they had these initial discussions. Um, you know, the other thing is it's most of this code I think that's going to show up for the compositing stuff will be in the browser side, so it won't impact the renderer code quite as much. Don't don't quote me on that though. So, um, oh, uh, so okay, the question is, if you force compositing on a child iframe, does it go through the same code path, or does it go through a what was the alternative? Sorry. Um, all right, Ken, are you there still? So the question is, if you force compositing on a child iframe, does it go through kind of the same code path as it does today, or does it get its own widget?
What do you mean by forced compositing? Because we this only works with compositing enabled. Oh, if you force composite, I don't think there's any. Sir, is it talking about like a local frame? You have a local frame. I can't hear the speaker, so.
Uh, I wish we had a mic.
Yeah.
Okay, this would be a lot easier.
Hey, so my question is, if we have a local root and has a child iframe that's local, so if you force composing on this child frame, does it get a web widget as well, or it doesn't?
Uh, at the moment, it does not, and um, I don't know. There's been no suggestion of adding that. So, is that Lucas?
Yes. And
Okay.
how would it be composited in that case?
How would it be composited?
I mean, wouldn't it just be the same as what happens today? Does a forced composite iframe get its own widget today?
No.
I can't imagine it does. So yeah, it would go through the same code path. So
Yeah, it's just it. I don't know that there's a way to tell an iframe to render separately from its parent. I mean, the rendering process traverses the frame tree, the tree of local frames, I should say, and then adds them all to layers. So renders everything into layers.
okay. So just to kind of finish up on the widget stuff, the code is in transition. So oftentimes you will kind of see cases for handling both web frame widget and web widget and some of the layout, animation, and that sort of code. That is something we are going to clean up once we can make web widget, remove web widget from web view. So web view will no longer be a web widget. Um, some other future cleanup I'd personally like to see is kind of remove web widget completely. Right now we have, I think, web page pop-up, which is also a web widget, and it seems kind of unfortunate to have kind of a web widget and a web frame widget and not, kind of try to merge them. So I think that's some future cleanup we could also try to do. Um, and kind of the final base change we had to do is the handling of window references for JavaScript. So for security, HTML has this split object model for window objects. And so what that means is each document actually has its own window object. So in this particular example, we save a window reference to a child frame, and then we navigate it. And then we assert that the cached window, I forgot to update that code. That W should be old window, is equal to the current window reference of the child frame. And if we didn't handle this correctly, this assert would fail, right? Because if you navigate a page, it gets a new document, so it has a new window object. And so the way this is handled in HTML is the spec defines something called a window proxy. And the window proxy is just kind of transparently redirects to whatever the active documents window is. So if you cache that window reference and then you navigate it, that's okay. Your window reference is not broken. You can still do stuff to it from there. And in Blink, this is implemented by a class called window proxy. It used to be called via window shell. So there's a couple problems, unfortunately. The original bindings code kind of dealt with local DOM window directly. I mean, this is expected, right? All the code was written with local frames in mind. So to address this particular point, we moved a lot of the common code that can be called into by bindings up into the DOM window-based class. And we did this regardless of whether or not you can actually access something cross-origin. So for example, in the DOM window-based class, you'll see things like window.console and that sort of thing. Even though you can't do that cross-origin, it's still there. And the reason is it would make the bindings a lot harder if it wasn't all in a base class. You'd have to have custom bindings code that would have to do this if is local frame check, etc. And since this should never be accessible, a lot of these methods on remote DOM window are actually just assert not reached because you should never be able to reach them. It is cross-origin and the security checks should always fail. And after we did that, we just updated the bindings code to use DOM window and it just kind of just works. Yeah. Okay, so if you try to touch those attributes or call things that are not accessible cross-origin, the bindings code will actually do a security check before calling the method. So it's not the actual method implementation itself that's doing the checks. All these security checks are implemented by the generated bindings code generally. Obviously, you can have some custom logic for this sort of thing, and some of the more interesting attributes have this. But in general, it is handled kind of a layer above the core code. And so moving things up into DOM window is enough to give us JavaScript access to remote DOM windows. So what's in progress right now is kind of updating the window reference that I was talking about earlier. If you navigate a subframe and it goes cross-process, you don't want to break the window reference. So that is a bit trickier. It involves updating window proxies so we can actually move the window proxies between frames because when you swap out local for remote, all the stuff that was on local frame goes away and that sort of thing. And right now, window proxy and all that stuff is tied to the frame lifetime. So in theory, this shouldn't be too hard. It's just updating a couple pointers. What could go wrong? So here's the fun part. How do you update your thing to work with remote frames? In general, I think it's useful to keep a few things in mind. One, I mentioned this earlier, but downcasting to local frame or remote frame is usually not a good thing. It should be a red flag that there's something that we could be doing instead. Another thing you'll see very often is the render just kind of assumes it can walk around anywhere in the frame tree, grab anything. We have something called top document, which is obviously going to be broken in site isolation because your top frame may not be in the same process, and that sort of thing. So you see a lot of these assumptions that are going to kind of have to be ironed out. Sometimes you'll have to move state into the browser or composite state together in the browser like we're doing for rendering and that sort of thing. And finally, sometimes you will have data races. We kind of mentioned this a bit earlier, and the conclusion is data races are probably okay, but it requires some careful consideration. So just a couple examples. So Shadow DOM, I don't know how many of you are familiar with it, so I just give a quick example. This example creates an awesome element, and then adds an iframe element in the Shadow DOM of awesome. And the idea here is, is that the top, interesting. The top document cannot see stuff under the shadow root. So it's kind of an encapsulation boundary. And one of the things is we need to filter out iframes, named iframes from that top document as well. So if the top document does window 0, it should not include the child iframe in the shadow DOM. And today, this is kind of implemented by tree scope checks. Unfortunately, tree scope is implemented by document, and a remote frame will never have a document because it's not accessible across origin. So one important thing to note is, at least from my investigation, every time you move an iframe element around the DOM, it causes it to be detached and reattached. And so given this, I believe it's sufficient to basically, we need some way to serialize a tree scope, maybe with some sort of integer ID. I'm hand waving a bit here because this is part I haven't written yet. And we use the browser to help replicate tree scope, this tree scope ID on frame creation. And because you can't really move frames around in DOM without this detach reattach, it's okay to just do it on creation. We don't need to do this overhead of actually replicating it and keeping it updated in real time. Because every time you move it, you're going to recreate the frame anyway. So that's just one simple example. Focus is something else that's going to have to be updated. Right now, page itself has a focus controller, and this focus controller has a focused frame. You're going to have to guess what it says. Nope. Okay. It's mostly legible. So, yeah. So right now, focus frame is kind of maintained as a local frame reference, and that breaks down with site isolation. Your focus frame might, be in a different process. And so our idea here is we'd like to split up the responsibilities. Essentially, the browser process will have to keep track of what the focus frame is, and each renderer can still keep track of the focus node. And the focus node is actually maintained on document, and so that's perfectly fine as long as we know which frame is focused. And so it's kind of this coordination. It's a little tricky because it will require syncing input events as well, because input events can run JavaScript, which might try to change focus and that sort of thing. So there's some subtleties around there. One saving grace is input events don't cross frame boundaries. So if you click in an iframe, that click event won't end up bubbling out of the iframe into the parent. There are a few things input related that kind of do bubble out, for example, scrolling. But we think we can handle that, and it doesn't actually, well, we'll see. We'll see how it goes. So here's another thing that might need to be updated is screen orientation. So right now, the browser process, kind of listens to screen orientation change events on Android. And when it changes, it tells the main frame, to be, hey, send a screen orientation change event. And that main frame will go to all its descendants and also tell them to kind of fire this event. And unfortunately, with site isolation, if you just go to the main frame, you might miss some frames that are in remote processes or rendered in a separate process than the main frame. So you'll need to update your code to, essentially all renders involved in rendering this page will need to tell them to dispatch a screen orientation change event. So the problem is there might be some issues with event ordering here. I didn't check the spec, but at least the way we've written the code currently, it kind of dispatches this event in a pre-order traversal order, right? So it goes from the top down and kind of dispatches events to each frame as it sees them. So if we want to maintain this event ordering, it actually might require blocking a renderer start to block on another renderer. And I mean, we haven't tried this, but it sounds like a recipe for kind of deadlock. So an alternative is to basically find all renderers in the page and tell them to dispatch this event at the same time in all the renderers, still in the pre-order order. The problem here is there are potentially observable side effects, all right? Because this is a JavaScript event, the JavaScript might detach a child frame during the processing of this event and that sort of thing. We're a bit iffy on this, but it might be okay. Like in theory, these pages are cross-origin to each other if we're kind of doing this in multiple renderers. So for them to kind of depend on some details of a cross-origin page seems kind of sketchy. Again, this is a little hand-wavy because we haven't tried it, but we're cautiously optimistic we can get away with kind of doing this in parallel and avoid this render is waiting for, child renderers kind of thing. So a little hand-wavy, but that's kind of one race. And finally, Fullscreen API is another interesting example of code that doesn't work with site isolation. So when you request full screen for an element, it goes through a bunch of checks. If I don't remember all the flags, but I think it's like one of the checks is if the element's browsing context is full screen enabled, and various things like that. And the tricky part about this is the final step of the check is to kind of repeat the check on your browsing context container if you have one. So that would mean like your iframe element if you're a child frame and that sort of thing. So this is where it gets particularly hand-wavy. There was a discussion on WhatWG a few weeks ago where someone was asking this question: how will we make this work if there were out-of-process iframes? And so I think we could, so I read the spec, and it seems like we could make it work by essentially tracking enough of the state in the browser to be able to, for the renderer, to ask the browser to kind of run these checks on its behalf. So if the full screen enabled flag is set for its parent context, that sort of thing. Another option is to kind of use the replication that Alex has built, but it might be more complicated and not worth the effort. Ultimately, you kind of need to go to the browser to kind of mediate this anyway. And so it might just ultimately be simpler to just do this particular check in the browser. It's kind of on a per feature basis, like depending on how we need to implement it. You could see kind of pros and cons to doing it either way. My personal bias is to basically just implement a synchronous IPC in the browser, and the renderer can be like, I'm going to request full screen, and are you going to allow it or not? There's more background on the WhatWG thread, which I linked. So if you're curious, I'm not 100% familiar with the full screen API either. There are some other potentially problematic bits. There's a full screen element stack, and if we need to maintain references to elements in the browser, I don't even know how that will work. So if anyone knows more about it, I'm all ears.
So I know that synchronous APIs from the browser to the renderer are strictly disallowed, but I thought they were also a really bad idea from the renderer to the browser. Like, what would be the downside of just making this more? It sounds like you already have to synchronize a lot of state. Why not just synchronize this too?
I mean, I think you could go both ways. I'm not really sure what would happen because I haven't thought through all the subtleties. Because there's a bunch of steps after the synchronous checks, and I don't know what would actually happen. If both renderers were, tried to start going full screen at the same time. Maybe it's okay, maybe it's not. It depends on how we have to order the events. We could probably make it work either way.
Embedder removes allow full screen. While the embedded content requests full screen. Don't you have a race there where the embedded content might be allowed to go full screen even though immediately beforehand the embedder removed that permission?
Okay, so this is kind of the cross-origin races I was talking about earlier. So cross-origin, you have no way to kind of have a synchronization point and say, okay, we both hit this point, now do this thing, and I can guarantee this happened, before or after that, right? Like, you can do post message, but that's not synchronous, right? And that sort of thing. So I think in that particular case, like the race is okay. Basically, the question is, where is it easier to implement the check, and where does it make more sense? I'm not honestly sure. I feel like replicating this whole full screen, all this full screen state, could be pretty complicated and something that would be nice to avoid. But at the same time, I can understand trying to avoid synchronous IPCs. Yeah.
So you're replicating security origin right now.
Yeah.
Is that a somewhat generalizable mechanism, like, because there sounds like there's definitely a handful of other flags and things that will need to be replicated. So um, is it just lazy replication, like one IPC to the browser and then it's broadcast, or is there anything fancier?
Alex,
Yeah, so currently it's a general mechanism. You can definitely add more flags to it, and it should be pretty easy. Currently, the replicated state is passed whenever you create a local frame or a remote frame. And eventually, it will also be updatable. So if you dynamically change the origin or one of these flags, it should also get an update message sent around and broadcast to all the affected renderers.
Is there any thought, I don't even know if this is necessary or if there's any performance issues. I just wonder if there's any thought of using shared memory or anything for that. I know extensions uses shared memory extensively for rather than synchronizing anything large. Or
we wouldn't want to do that between renderers. As soon as you start sharing memory between a potentially exploited renderer and then others, we wouldn't be mapping them into the same sandbox space. But I think, yeah, we're looking for basically just a mechanism to pass this information on with the IPC mechanism. So it'd be shared memory with the browser process is the way most IPC messages work.
Anyway, yeah. So I came up with this idea kind of before we had any of the replication stuff in place. So certainly, we could certainly reconsider. Like I said, I'm not super familiar with the Fullscreen API, so I haven't thought through all the potential implications. So it's hard for me to say without actually implementing it myself. I think this is one of the things where you kind of have to try and see what works out best. Yeah. All right. So testing. Unfortunately, our testing is not great in Blink at the moment. We have some kind of basic unit tests for just web frame swapping, just kind of sanity tests that we don't trash the frame tree pointers or that sort of thing. So it's pretty basic. My future plan is to kind of update frame test helpers to, today you can kind of create, web local frames with kind of a stub web frame client and that sort of thing. And so you can do kind of any sort of unit testing you want in it. And I'd like to kind of extend this to work for web remote frames as well. So if someone wants to test something, they can just call swap, and they can get a web remote frame with kind of wired up to a web local frame in the same process. It's not going to be cross-process, but we can simulate it enough in unit tests that I think people will be able to do meaningful things.
so any thoughts about being able to do anything from a layout test?
Interesting you asked that. Currently, we have no layout tests. So one of our Q1 OKRs is to actually start running the stuff under the HTTP security tests, just because a lot of those are kind of cross-origin in nature, and we're hoping we'll kind of exercise at least some of the frame creation, the frames replication, all that stuff. Down the road, it's not clear what the best path is. So one potential kind of really hacky idea I had in mind is find some way to implicitly wrap all layout tests with kind of a hidden remote frame at the very top level. This is actually something that might be useful for WebView down the road as well, because in WebView, something inside a WebView can't see its parent and that sort of thing. And so if we kind of have a way to hide that already, we might be able to reuse it for layout tests, and it might just be enough to exercise a lot of the important code paths. Probably we'll have some way of forcing a cross-site frame to be created as well. But I wouldn't like to see everyone have to essentially start writing, 2 unit tests for everything they change, right? A non-site isolation version and a site isolation version. So, that was kind of my best idea at kind of a reasonable way to kind of simulate, exercising at least. You can't assume your mainframe is always local, that sort of thing. I don't know what will happen if your mainframe is not equal to your top frame. That could be interesting. So there are certainly some details to work out there. And if anyone else has better thoughts about this, we're all ears. So yeah.
But those layout tasks, they in Blink, it would be running on a single process, right?
No. So the idea is we would try to run the layout test for HTTP test security with dash site per process, and that should, in theory, kind of force cross, iframes that are not in the same site instance to be created in separate renders. The thing is, a lot of the layout tests aren't actually cross-origin, right? Like if you look at a lot of stuff under CSS or rendering or layout, editing, all that stuff is almost certainly going to all be in the same process because, it's using, whatever. So.
The thing that comes to mind is that, yeah, most tests are only in one origin anyway, but tests that specifically are about iframes might be really great to be able to test all of those both ways. Like, I wonder if it'd be possible to, like, I know I've written a lot of accessibility tests with iframes, and I often use data URLs or just other local things, just because the point is just to test the basic interactions of an iframe. It has nothing to do with origins. It'd be neat if there was some way to write a layout test, a simple layout test, and force something to be remote, whether it's in a different process or not, just to test sort of the remoteness of another frame. So it's just a thought.
Yeah. If you have ideas about what that sort of API might look like on, say, the test runner or that sort of thing, that would probably be really helpful, and we could certainly try to implement it. Well, not try to. We'd probably implement it because it's kind of important to be able to test things. So. Was there anything on the dory? I didn't check. I'm assuming not. Does anyone else have questions? I can't guarantee an answer, but.
Okay, so I have another question. I'm trying to better understand now I'm trying to remember the name, the web local frame, like tree root or something like that.
Yes.
Well, here, let me ask a concrete question then. So suppose in Blink, suppose I've got two HTML elements. How would I find out if they're part of the same site instance versus how would I find out if they're part of the same tree root?
Well, you could just call local root and see if your local root is the same, right?
What do I call local root on? Is that something of the document of any
Something
frame?
we'll be exposing off. I don't remember without looking at the code right this instant, but it's either going to be available from local frame or web local frame, right? You can only have a local root if you're a local frame to begin with, by definition, because local roots.
Yeah, and if you have an element, obviously you have a local frame.
So,
okay.
So you will
Usually Blink will assume that local frames are part of the same site instance because there isn't that much interaction between the frames. Perhaps for, I guess, I guess you have to have synchronous scripting between them, but that's probably about the only case. Like, that you'd have local frames that are under a different local frame root actually communicating in any way, because they, like rendering and hit testing is all localized to just the one local root and its subtree.
No, that definitely makes sense. I don't even necessarily have a scenario in mind, but I'm just wondering as like looking through the code, if you've got an element and you're not sure its relation to another frame. It sounds like there are a couple of cases where it's more important to look at the frame root versus looking at the site instance.
Yeah, you can still block the entire frame tree, including the remote frames, right? But
I think in general the renderer shouldn't really have to care too much about the whole site instance business. That's something for the browser to essentially enforce. Obviously, the renderer still needs kind of the security. It checks for cross-origin stuff, but like other than that, it should kind of be able to just work with whatever it has, regardless of origin, right? Like that sort of thing should be pretty transparent to like the layout code, because layout code is obviously going to cross origins, right? If you're laying out frames that weren't rendered cross-process, that sort of thing.
Yeah,
So.
it basically boils down to if it's another local frame in the same process, then it's probably the same site instance.
But it might not be. Oh, sorry. Well, it's the same
If
site
it's
instance,
two
but it's
local-
not necessarily the same local root.
Right.
So
So
for
you can either have the same root, or you could just be another local frame with a different root. And those are kind of the two cases. Like you're sharing a widget or you're not.
got it. Okay.
Yeah. Okay. That's it. Thanks.
Okay. Yeah, thanks again. As I mentioned, we've got plenty of time for more Q&A on Blink stuff now or discussion. And then if you want to grab any times on our calendars, we're here all day the rest of today, tomorrow, and Wednesday. So obviously there's a lot of things that we should still sit down over some code and figure out how they're going to work, and places that we can figure out the right balance between complexity and performance. But you know, we're hoping we're making progress on all these fronts. So thanks for your help. Yeah. People can come and go as they want at this point, but we can keep chatting about it.
I just want to throw out a random question. If this is a terrible idea, maybe we can just discuss why. It would simplify. I was thinking some of my accessibility code for out-of-process iframes would be simplified if I could track the frame tree node IDs in the render process too. So I'm just throwing out as a straw man, what would happen if the same way we synchronize security origin, could we just synchronize the frame tree node ID? Obviously there might be a slight time when something's created where it's not quite up to date, but it seems to me like it's not something that migrates around unsafely. So is that something that's possible?
I can't think of a concrete reason why that would be a problem right now. I think the frame tree node ID probably gets created around the same time as the frame routing ID.
Routing ID.
Okay. It's on the I/O thread from a synchronous IPC, and the frame tree node ID gets allocated on the UI thread slightly after that. So you may not have it right after the frame is created. Is this mainly for the purpose of echoing it back later?
Yeah, well, right now we're doing a lot of dances, like every time, like in the parent frame, you've got an iframe element, and it wants to pass through back to the browser process. Here's my child iframe. It has to pass the routing ID, but that's the routing ID for the frame proxy in the browser process, which then we map to the right frame, which then we map to a frame tree node ID. And we do this every time it changes, and it's a completely different process going backward. And so I'm thinking, why can't we just store that in the render process? Maybe we don't have it immediately, but we'll certainly have it within a couple instances of when the everything gets hooked up long before navigation completes, and then essentially from any iframe element, I could say, well, what's the frame tree node ID of that child? And from any child, I could say, here's my own frame tree node ID, and here's the frame tree node ID of my parent, which I get from the remote frame.
Mm-hmm. Yeah, it does seem like that's the type of thing we'd want to verify somehow in the browser process.
Yeah, I was just going to say you cannot trust that value coming from the renderer. So your code needs to be written in a way that even if it comes, so you avoid doing a couple of lookups or something, you still need to validate that this indeed makes sense.
Well, it might be easier to validate in the sense that if I just had a pair of IDs, I could just validate, say, hey, are these IDs from the same site instance? If so, then they're fine and I can trust them. That seems easier to me than right now where I'm kind of searching for the IDs as opposed to just verifying that they're correct.
I wonder if we can make that conversion a little simpler so that it's not as much of a task. Just from the sense of having them be separate layering, separate layers of code where the frame tree node ID is something where Blink and lower layers probably shouldn't care about it too much. But if we can make the conversion between them simple enough, we might not need to.
It's not exactly the conversion is complicated. It's just that I guess it's just that the reasoning to think from a parent to a child is so different than from the child to a parent. it it just seems like we're eventually converting everything to frame tree node IDs anyway. But anyway, we can explore it.
Yeah, we can take a closer look at like a concrete code example.